In the world of AI, there's this constant race to build bigger and bigger models. But what if the next huge breakthrough isn't about size at all, but about being smarter? Today, we're diving into Z-Image, a lean new model that's really proving that smarter might just be the new bigger.
And that really is the question, isn't it? It feels like every month, these AI models just get bigger, way more complex, and unbelievably expensive to train. But is that brute force approach, just throwing more power at the problem, the only way to get those amazing, state-of-the-art results? Or is there a smarter path?
For a while now, AI image generation has felt like a full-blown arms race. The thinking has always been, build the biggest, most powerful model you can, with this belief that just adding more scale automatically equals better quality.
And this slide, it just perfectly captures that conflict. Over on the left, you've got the current trend, these massive models with tens of billions of parameters. Think of parameters as, like, the little knobs the AI turns to learn. The more knobs, the more it can theoretically learn, but it also gets so expensive to train that it ends up locked away behind a corporate paywall. But on the right, that's the dream, right? Especially for the open source community. Getting that elite quality, but with the efficiency and access that actually lets people innovate.
Okay, so this is where our story takes a really interesting turn. A team over at Alibaba decided to challenge that whole bigger is better philosophy. They wanted to find a different, much more efficient path. And their answer is a new model called Z-Image.
And they are not shy about their mission at all. This quote from their research paper says it all, loud and clear. They are directly taking on this idea that you have to spend tens of millions of dollars and just use brute force to get top-tier results. So how did they pull it off? Well, it wasn't some single magic bullet. It was a really systematic end-to-end rethink of the entire process, built on 4 core pillars of efficiency. These 4 pillars are basically the secret sauce. A smarter way to handle data, a totally new model architecture, a more logical way to train it, and a faster way to get the final image. So let's break each one down. First up, the data. Now, instead of just shoveling trillions of random internet images at the model, Z-Image uses this super sophisticated curation system. It actively hunts for high-quality, aesthetically pleasing, and conceptually rich data. By focusing on quality over sheer quantity, the model learns way more from every single example. It's like the difference between reading a whole library of random books versus reading a curated list of masterpieces. This precision is a huge reason they could cut down the training time and costs so dramatically.
Okay, now this is the real architectural breakthrough. A lot of models handle text and images in separate streams. It's like having 2 people in a room having totally different conversations and only occasionally passing notes. But Z-Image's single-stream architecture, it puts them in the exact same conversation. Text and image data are interacting and learning from each other, together, at every single step. This deep integration is what makes it so incredibly efficient. The model builds this richer, more unified understanding with far, far fewer resources. Next up, the training process itself. Z-Image is trained kind of like a student following a curriculum. It starts with the basics, learning general concepts on low-resolution images, which is super cheap computationally. Once it has that foundation solid, then it moves on to the harder stuff, higher resolution, more complex tasks. This progressive learning is just so much more efficient than trying to master everything all at once. It saves a ton of computational power and builds a much more robust model in the end. And finally, we get to speed. The team created a distilled version called Z-Image Turbo. And the analogy here is just perfect. Think of it like a student model that learned all the shortcuts from its expert teacher. The result? A model that can spit out a final, high-quality image in just 8 steps. I mean, that's fast enough for real-time applications, which is a massive leap for a model of this quality. So the philosophy is smart, the tech is clever, but does it actually perform? Let's look at the numbers and see if this whole efficient approach truly delivers that state-of-the-art quality they were aiming for. All right, after all that talk about efficiency, here's the big reveal. How big is this model really? Just 6.15 billion parameters? You have to understand, in a world where models are blowing up to 20, 40, even 80 billion parameters, that number is just shockingly small.
And this chart just puts it all into perspective, doesn't it? I mean, look at it compared to other leading open-source models. Z-Image is less than 1/3 the size of QuenImage and just a tiny fraction of Hanyanyan Image. It's like a middleweight boxer stepping into the heavyweight championship and holding its own.
And of course, that smaller size translates directly to cost. The entire training run for Z-Image cost about $628,000. I mean, when you hear about competing models costing tens of millions of dollars to train, that number isn't just impressive. It's a potential game changer for making top-tier AI accessible to way more people.
So, here's the million-dollar question. Does it actually perform? Well, according to human reviewers on the public AI Arena leaderboard, absolutely. Z-Image Turbo is ranked 4th globally. It's beating out many larger models, and get this, it's the #1 open-source model available. It is punching so far above its weight class, it's incredible.
The numbers are impressive for sure, but the images are what really matter. And you just have to look at the results. Z-Image generates these breathtakingly photorealistic images. The detail in the skin texture, the subtle way the light and shadows play, these complex cityscapes, this is the level of quality you'd expect from the absolute top-tier commercial models, and it's all coming from this lean open-source competitor.
And here is a standout feature that so many other models really struggle with: text. Z-Image is amazing at rendering crisp, accurate text inside of images, and it does it flawlessly in both English and Chinese, which is just a huge testament to its sophisticated training and that unified architecture we talked about.
So, when you look at all of this, what does a model like Z-Image really mean for the future? Well, it could signal a huge shift in the entire industry, a move away from brute force and a turn towards intelligent, efficient design.
So let's bring it all together. The biggest takeaway from Z-Image is that you don't need massive scale to get elite AI. By focusing on efficiency at every single step, from the data to the architecture to the training, it's totally possible to deliver top-tier quality, including amazing photorealism and complex text, for just a fraction of the cost. And that means high-performance open-source AI is becoming more accessible than ever before.
And that brings us to our final question. Z-Image is more than just an impressive model. It's a proof of concept. It points to a future where elite AI isn't locked away in some massive data center, but is efficient enough to run on our laptops, on our phones, in the hands of creators everywhere. What happens when that kind of power becomes truly accessible to everyone? Now that is a very exciting future to think about.